Doctori, tutto a post? So welcome back to a new video. And the topic for today is still looking at IOU ring and how to implement an IOU ring backend in SC Async Library. So what is SC Async Library? Is part of Sane C Libraries, which is again one more a platform abstraction, a set of platform abstraction libraries for macOS, Windows, and Linux that has fast compile times, it's bloat free, it's simple and readable, easy to integrate. It doesn't use the C++ standard library and has no third-party dependencies. So check it out on GitHub, give it a try, and make sure also to join the Discord link below in the description if you would like to get in touch with me or other persons that are enjoying this way of doing C++. So let's go back to our what we have been living in the last video. So in the last video, I think we got to a point where we were able to run a couple of tests, even more than a couple. Actually, these are a couple of async objects. So this is really really the basic stuff. Now we have to go into the more advanced stuff. So let's try to see if we can get any of the socket stuff to work. So I'll go to my table. So for accept, I need to do a prep accept. This API is kind of nice. The only thing I'm not understanding, I don't want to say I don't enjoy, but maybe it's just me not understanding, is why this is not part of the sysroot compiler for Linux, or it's like a standard header, but it's something you need to install it separately. But maybe there is a reason, and let me know if you know what's the reason. So let's do a socket. What is accept? So I think we just need activate and cancel, because these are all asynchronous operations that we want to reactivate every time we need. So I'm going to do the prep accept here, and this will become socket accept. What does a prep accept need? Of course, it needs a submission, just like everything. And so we'll give it a submission, we'll set the data, and we can return true if everything is all right. So we need an SQE, which is our submission. We need an FD, which is our async. I think we have the file descriptor here. What's its name? Handle. We need the handle. Async handle. Then we need a socket address and a socket len. And also this ones must be stable for the entire duration of the until we submit it. Yeah, this is kind of similar to what is done here on the Windows backend. So maybe, because also the Windows backend needs you to keep this accept buffer. Actually, this is even worse because you need to keep it for the entire duration of the completion. But while IOU ring just needs it until you submit, we don't have this difference between like memory that is stable during submission and until the completion. So it's just a single category, but I guess it's right. So here I need to add what is the type? A sock add. Okay. I think I've been using this elsewhere. Let's see, because I cannot clearly put this into header, because that would violate one of the principles we have in Sane C libraries, which we cannot include any system thing in the public headers. So let's see if I have been using it elsewhere. I think so. Yes. All right, but I think I have it in a handle. Okay, Perfect. So I already know that I'm using an aligned storage of 28 bytes, and this is enough for using this. Beautiful. That's exactly what I'm going to do here. So aligned, so this is an aligned storage of 28 bytes. So this is my sock add buffer. I don't know, maybe I'll rename it. So we can make sock add equal async dot sock add buffer, reinterpret as sock add. So this is very simple class that allows you to create storage, and then you can reinterpret as something else. It at least checks that you're trying to cast it to something that is smaller than the size of the buffer. So which is the minimal thing you can do, but I think it's enough. We also need the socket length. I think socket length is int32 sock length t. What is it? It's just an int. Okay. Well, why not? So let me make it just int32 sock len sock. Should I fill it? Probably yes. Oh, this is an accept. So it's the OS that it's going to tell me how this is. Oh, my light is shutting down. All right. Socklen. I don't know. Let's put it to 0. Probably should be reading the documentation for this, but I have an intuition of how this could be working. So let's do it. Socklen flags. No, this one I don't know, so I need to check it. Do I need any flags? Let's see. Flags. What are the flags? Modifier flags. Using modifier flags in flags, which doesn't say exactly what flags is. So it's the same as accept for. Okay, so I can use the same. Oh, so it's the same as accept, of course, yes, because they all mirror. Oh, so I can create non-block and exec, of course. All right. Yeah, I want it non-blocking and I want it no exec. I like this. So what about the cancel? I think for the cancel, we can probably survive with some generic cancel, because now anything that is not a timer that has a special cancel function, timeout remove, and it's not a file poll that is the prep poll remove, I think we have a generic cancel somewhere, which I have seen. IO uring prep cancel. Yeah, this API is nice. This API is nice. It's just, the delivery of the library that is puzzling me, but the API is really nice. It really maps easily into decent abstraction for Async I/O. I don't want to say good. I would say it's decent, my abstraction. I will let you tell if this is any decent. So we submit, yeah, it uses the user data, of course, to identify the previous, so I want to make this generic. So yes, I should restore the template. So this is using the basically the user data that we are putting here to know which one you want to cancel. And to do the cancellation, you need another SQE. Makes sense. So I want to do it. Is it accepting as a void star? Okay, so I can just pass the address of the async. So this is again, this is the same address we are setting in every request. That's how we are going to cancel things. Flags. I don't know what are the flags. Let's see. Cancel all. Cancel FD. No, I think I don't need any of these. They look very special cases. Just cancel regular stuff. I probably don't need to. Should I set any data here? Probably yes. All right, let's try to do the socket accept test. Error. Invalid connection. Oh, it's an unsigned hint. All right. Yeah. Anything that works for you. Fail. But we arrive in the callback for the test. So it means that this is kind of working, but we are not setting the client. So I need to do a complete. Yes. So in the complete, I have my, yeah, complete async, and this as the result. And in the result, I need to write the accepted client. Where is the client? The client should be in the completion, which is the IO uring CQE. So I should do, I think we have the event index in the result or in the async, can't remember. Let's see. Async event index. So this is the index of the completion. What's the name? Events, event index. So this is our IO uring CQE completion. So this completion has a result. Will this just work? So maybe I can just make it like this. Let's see. No. Error. Oh. Let's try, let's see if we can get to the completion. No, we are not arriving into the completion. Why? Are we arriving in the accept at least? Okay. This one is something we are arriving. So are you telling me that we are hitting an error in the validate? Let's see. No, completion is fine. So why is this not event index? Should go in the complete. Why are we not invoking the, wait a minute, what's going on? What's going on? If you call things like complete async, just like in my Italian accent, things are not going to work. Oh, this is shutting down all the time. I guess it will be a constant part of this video. Yeah, so we are incomplete. We are assigning the new accepted client socket, and we're doing one more, and we segfault. Why do we segfault? Well, is this test calling close explicitly? Yeah. So we are calling 2 times the close, which is not a good idea. So bool ring initted is false. If ring initted, we'll exit, and then we'll ring initted true. Ring initted true. Sorry, this is false. Let's see. Error. Size mismatch. Okay, we have to increase the size of our pimp object from 296 to the 304. So this is the mechanism I'm using to completely hide all of these types behind in the source file, so away from the header, but without needing to do an allocation. So this is statically declaring an array of bytes of this size, of course aligned to the proper alignment, and then calling the placement new to construct this internal object where I can put all of my internal stuff. And the test succeeded. Yeah. Very good. Let's do socket. I think the next one is, let's see, socket connect. So socket connect, it's going to be similar. Let's see if it's going to be easier or not. Socket connect. So socket connect is async. Let's do a socket connect here. Oh, what do we need? We need an FD. Okay, so this is like connect, right? How does connect work? Async POSIX connect. Where is, oh, I'm using the socket client. So connect wants the open socket, the socket address, and the size of the handle. All right. So async dot, where is my handle? Is it handle? Okay. Then I need the socket address and socket length. But I have this IP address. But the IP address in socket IP address from the socket library is exactly the native representation of IP address. So it's exactly a socket address, just disguised under this pimp implementation hide mechanism. So I can reinterpret it like this. IP address. No, I think there is a how am I reinterpreting it? Let's see. Yeah, this is exactly what I need. Native size, I need to do size of handle. Okay, let me copy this. So this is the native size, and then I need this reinterpret cast of the IP address to socket add structure. Oh, I'm even making it const. No, I don't think we need to go that far because this API is not. Oh, it's even const correct. Wow, beautiful. Again, this is getting better as I proceed. It's getting better at every step. Well, I think I can just say IP address. So this is async.ip address.size of handle, like this. So here we are doing a connect. We are passing the native handle to a socket address structure that contains the destination IP we want to connect to. And the size of handle is, I think it's used because this way it can discern if it's an IPv4, IPv6, and you know, that's how the OS is doing that. So this has no member named accept client, of course, because we are connecting, we are not accepting anything. So if we arrive in completion, I think we just have to set the return code to result true, and we can return a result true. Oh, this is just a bool, so just true. Does it compile? It does compile. Does it run? It does not run. What am I doing wrong? Are we arriving here at least? Okay. Well, at least we are arriving in both. So what's wrong with this? Test socket connect. So we are getting to the accepted or not. So connected count to accepted count, and then we are not ending. Are we even arriving here? Okay. Oh, because this is using the receive. Oh, why am I using the receive in this test? Well, so when implementing the socket connect, I need to implement also the socket receive. So the connect looks like it's working because I got to the callbacks telling me that I actually got connected. And let's try to implement the socket receive. Yeah, the light is off, light is on. Activate async. For socket receive, what's the function I should be using? Socket connect, socket send, prep send. No, I need the receive, sorry, prep receive. Well, this is starting to get just a lot of copy and paste, but let's see if there is any special stuff I need to do. Submissions, sock fd. So this is async handle buffer async dot, where is it? No, it's not called buffer, it's called oh, this is not right. Async socket receive. So this is async dot what? Data. So what does it want? The data buffer and len. So this is data and data size in bytes. Flags. I don't think I need any special flags. yeah, am I using the receive here? Let's say in the POSIX, async POSIX receive. Yeah, I'm not doing any special flags. So that's going to be good. The result, I think we have the read data, which needs to be set to be result async data slice start length 0 length in elements result length in elements are the written bytes, which I assume we are getting in the events result. These are like auto written bytes. Even const. No, this is a receive. So these are the read bytes. Read data, yeah. So all APIs that can fail return a failure in this framework. So when you, even when you want to just slice an array, the array where your slice should be written to, the span, sorry, it's the last parameter, and this function is returning a bool in case you are passing a bogus offset and length in elements. Instead of asserting or throwing an error, this is just failing, and it's forcing you to check the result because this is not discard. Does it work? Let's see, are we getting any sensible value here? Read bytes 1. Yeah, I think I'm reading and writing bytes one by one. Yes, I'm probably writing 4 bytes and reading them one by one. I think no, I'm reading and reading and writing a single byte. Yes, receive buffer is 1. Cool. We have socket receive, so I guess we need to do the send, so I can have the send and receive test working. Well, this is easier than, yeah, this is easy because it's really mapping one-to-one the API. Socket send, and there is these are basically the same, the asynchronous versions of the corresponding POSIX APIs. So if I go in async POSIX and I go to send, yeah, that's exactly what I'm going to do here. So I will need a handle, I will need the data, size, and I think this is right as is. These are not read bytes, they are written bytes, and this is not read data, this is oh, does it have any sort of result? Oh, it's just called data. All right. As no member data. Am I looking at the right thing? So, okay, there's no, oh, so send has no, it just has the success or not success. Okay, result dot return code is result true then, and we return result true. So this is again the activate, and this is the complete. And this is how you cancel it, but this is common to many a type of async operations. Send and receive, run. No, yes. Yeah, it works. Beautiful. Now, send and receive error. Why it's called error? Because I am canceling. Yeah. Okay, I don't know if this is going to work. This is going to work. So are all of them working so far? Oh. Why do I have the Italian keyboard? Let's try. Okay, the wake up is not working. Well, we'll see it later. Maybe I'll debug it later. Let me finish the... Is it just the wake up stuff that doesn't work? Oh, it's the timeout. Oh no, the process exit, sorry. The process exit was not done, so... Yeah, sorry. So these are working, all right? Please tell me they are working. Yes, they are working. Let's do a socket close. Well, this is going to be also easy, I suspect. Can I just do socket close? It's called prep close. Yeah, lights. Socket close, just the FD, async dot handle. And this is going to be working. All right. So we have file read and write and file close. File read and write. So I need to implement file read and file write. File read. Activate async. Async file read. File read. Prep read. Submission. FD async. What's the name? File descriptor. Buffer async read buffer data async read buffer size in bytes offset async offset. You know, the mapping of the async objects is really one-to-one. I already verified before doing this video, of course, but so it doesn't come as a magic thing, but it has been designed this way. So in the read, are we returning anything? Yes, we need to create the read data. So result dot read data. So result dot read buffer. No, async read buffer. Slice start length 0. And we want to put it into the result read data. I need the number of bytes, which are this ones. This is similar to the receive. So I'm going to read bytes, and these are my read bytes. See, problems. Cannot overload data based on conversion void. Okay, sorry. Forgot the ignoring return value. Oh yes, return. That's why I love this, you know, this card. I want to check return values. Of course, this is not working because I need to implement the file write. Let's do the file write. File write, file read, file write. Prepare a write. and this is write buffer, and yes, it does take the offset too. So async write buffer, these are like written bytes, result write. I'm just writing the written bytes, so not okay, not a span. Let's see. So it does want just the written bytes. Okay. All right. Let's run it. Yeah, file read write succeeded. So this is going really, really good. File close. Well, I do not expect this to be problematic at this point. Let's do, I mean, I can do a file close. Let's copy the socket close. Actually, it's the same as the socket close. I think it's still close. Socket close. Oh, where socket send. Oh, I forgot to change the command. Socket close. And let's make it file close. File close. Async file close. Prep close. That's going to be the same. Actually, it could be, oh, this is called file descriptor. Yeah. Could be rerouting this to the socket close one, but let's do it. Beautiful. File close also, it's on our side. So I think we need just a big boy here, Mr. Process Exit. So let's do process exit. For process exit, I thought I would have been trying to use this pdft open, which for some obscure reason doesn't come with a pdft open function unless you are on some later Linux kernel. And even the non-block flag, it doesn't exist in the headers, but it's made the same as sock non-block. It should be like pdft non-block. But anyway, so let me just search how this is meant to be called. Yeah, since Linux 5.10. So I need to include sys and syscall. Let's do it. What was the syscall name? This one. So this is how we open a file descriptor such that we can get notification from the kernel about child process, let's say needing to that is closed, that is closing, or it's terminated, and we should poll it. So I should create this. Let's see. Process. Process. Oh. Exit. Lights. Using process exit. I'm going to create the FD Maybe let's make this a result. So in PDFD, if PDFD is less than 0, return error PDFD. So I want to store this, right? So let's make it LFSC platform Linux, file descriptor PDFD. So async PDFD assign PDFD. We try to assign it. And I need to do this in the setup. So just the first time, because then I need to do poll and poll this PDFD so that the operating system can tell me when the process has terminated. Right? Poll mask. What do I want to poll mask? Poll in or pull out? I don't know. I think it's pull in. How do I cancel this? Can I guess I should do the poll remove. So I should copy this. I don't know if I have a test testing the cancellation for this one. So this is probably not going to be tested, but I will add anyway. Eventually test it and you know, fix anything that doesn't feel right. So I want to do this, and I would like also to close the PDFD. Yeah. Let's make it result, maybe. Problems. PID was not declared here. Oh, okay, I need the PID. Async.handle. Yeah, because PDFD don't block does not exist, right? Let me copy it from here. Yeah, this doesn't work. All right, maybe let's do it like this, you know, so I remember. So I have been reading somewhere when I was trying this that this is meant to be defined in some header but does not exist, but it does have the same value as sock non-block. Process exit. So we got almost until the end of the test, but we don't have the exit status because I need to fill it, right? Result.exit status. I think here, once we are in the complete, we should just do a wait PID, which we do elsewhere. Right, so I just need this code. And my exit status is here. Let's see. So we don't have wait PID. What do I need? Syswait. Include syswait. So we have wait PID. What's our PID? PID is result.async.handle exit status dot status. We don't have an exit failure. Well, I don't care if it's an exit failure actually, so I just want to save the value. And what if this is different than 0? Should this return error if it's different than 0? I think this is to do check what is the correct value here. Yeah, because if the status is less than 0, this is meant to be returning an error. POSIX API. All right. Or should I do it like this? Maybe. I don't know. I need to check this documentation. Ooh. So even our test, the last test works. Let's see. Async test. Can we try to enable all of them? All right. Excellent. Really good. So this works. This works, and of course, my test suite is very simple. It doesn't test all of the cancellations for every async object, but even being able to just execute the test to this level is already a very good result. So I'm extremely happy. I think I will try to improve this code a little bit. One thing that I would like to do is to make sure I'm really handling the cases where the completion queue is full. So probably here I should be, sorry. I should be testing if this is returning some error code telling me that the completion queue is full, and copy the completions and call the callbacks for them. And I need to do it probably also, so some sort of flash submission similar to what we have done in the macOS backend, so that when I create a submission, this is where I need to do it. I need to flush the submissions if I cannot get any submission slot ready for me in the ring buffer. So I think this kind of tweaking can be done offline, maybe not immediately, but later on. I would like to try improving the test suite, for example, to really test cancellations for every each single one of these operations. So I'm sure that some of the code that I wrote is actually tested, because I'm sure that some of these are not tested at all, some cancellations, and these are important because you may want to be sending an async operation, but you also want to be able to cancel it. And this will make the entire library a lot more stable. So I will add and commit this async Linux file with support, initial support, let's say for IOU ring. This is not complete. This is, draft. It's something, this is just being started, but we have to start from somewhere. So I hope you enjoyed the video. Make sure to leave a like if you liked it and write a comment below. Make sure to join the Discord so that you can get in touch with me or any other person interested in the project. Make sure to check out the GitHub and clone and play with the project. And let me know if there is anything that you don't feel it's right from this video, and so we can discuss it. See you next time on the next video. Enjoy, have fun with Sane C++ libraries. Goodbye.